Thanks very much, Tim, and thanks everyone for the opportunity to speak at your conference. Good safety cultures don't just happen, they need to be created through the involvement and empowerment of the team. This is the story of how my colleagues and I achieved this in Chevron's Rosebank project. In the course of the presentation, you'll find that there's three main themes. The first one's working together. So that's where the involvement and empowerment of the people comes in. The second one is structure, because we need to have some form of framework to hang the safety culture on, because what we're trying to do here is we're wanting to create order, not chaos. And finally, and perhaps this is the good news, or maybe it's the bad news, is that there's no real new techniques here. All we're trying to do is use existing, tried and tested techniques in a slightly different manner. I should apologise up front. As you've probably noticed, I've got a very strong Scottish accent. It's not the first time that you'll have seen this at an oil and gas conference. I've left the subtitles at home, so I'll just need to speak slowly. Okay, Rosebank itself, what is it? It's one of Chevron's major capital projects. It's currently in the front-end engineering design phase, and we're looking at first oil in 2021. Perhaps more interestingly, it's 100 kilometres west of the northern tip of Shetland. That means it's about as far north as you can get in the British Isles. And secondly, it isn't in the North Sea, it's actually in the North Atlantic. In 1,100 metres of water, it's just off the continental shelf. So as you can imagine, we've got some pretty challenging weather and sea conditions here. The actual development itself, it's multiple wells manifolded back to a passive weather veining FPSO, oil export by shuttle tanker, gas export to the beach via pipeline, and produced water reinjection. It's maybe worth just clarifying what process safety management means to us in Chevron. Effectively, it's a subset of major hazard management, and it's all about keeping the hydrocarbons inside the process where they belong. However, we're not just looking at the design phase here. This is a whole of life cycle approach we're taking. So we're looking forward not just to first oil, not even just to 2028, but way beyond that, probably long past my retirement date. It's also about regulatory compliance, because in a risk-based environment, if we can get the risk-based design right, then we've probably get good regulatory compliance. Okay. Patrick talked about levels of engagement in companies. Here's what engages me. We've got an absolutely fantastic opportunity at the design phase in the project, because any hazards that we design out or control now will remain that way for the whole life of the field. So we can make a big difference to Chevron's overall safety performance by getting this design right. The second big opportunity we've got is that we can look after people that we'll probably never meet. And that is one of the things that gets me out of my bed in the morning. And I was more than happy to tell that to anybody in the Rosebank project, those that were willing to listen, and even those that were less keen. But there is another side to this as well. And if we look at all the loss of containment incidents that have occurred in Chevron over the years, we find that over 30% of them have got design as a root cause. Therefore, if we can deal with this 30%, then we're going to overall improve the company's process safety performance in the long term. The company's done some analysis in that, and we find these two key themes stand out. The first one is design standards not getting used. Now, is it because folk weren't motivated to use them, or because they didn't realise they were there? We don't know. However, one thing we do know is that these are all lessons learned from previous incidents built into codes. So it's very important we use that as a basis for the design. So one of the focuses of this process safety culture that we're trying to create is to change people from the inside out, to get them to use these codes and standards because they see the applicability and the value in them, and not just because somebody told them to. So in that respect, we're operating in the left-hand side of the four-quadrant model that Alan showed you earlier on. But that'll only work if we get the right-hand side right as well. So we made sure that we provided the relevant codes and standards, and we made it very clear to people in what order they applied. Frank Zappa once said, "Without deviation from the norm, progress isn't possible." Now, let me make it clear here. I'm not suggesting rule breaking, and I'm absolutely not advocating anarchy. What I'm suggesting is that in an environment like this, we need to do something different. So it needs a bit of inductive thinking about making the design resilient to conditions that we might struggle to anticipate. And that, for me, is the essence of inherently safe design. So as I talk through the presentation, these are the kind of things we're trying to encourage in the team. And of course, because we're dealing with some of the big ticket risks here, we're going to need multiple barriers between the people and the hazards, which means that these work best when we've got diverse barriers, which means we need diverse skill sets, which means we need to have everybody working together. Of course, we need something to hang this around too, and most companies have got their own golden rules. Chevron's no different. We call ours the Tenets of Operation, and they're based in two key principles: do it safely or not at all, and there's always time to do it right. And I'll come back to that second point a little bit later on. I won't read through them all. You can see them behind me on the screen. But I've highlighted the last one because if we get the right people involved at the right time, and there's enough discussion and debate within the project team, those other 9 ought to follow. But as you see them up on the screen there, you might think, well, that's okay, but how do we get folk thinking about these? How do we get people personalizing them and using them? So what we did was we produced a series of safety moments at the start of meetings where we would go through one tenant at a time and just get people thinking about how it might apply to the design. And that way, the people started personalizing the tenants, and as they were thinking them through, it made it more likely that they were going to get used. Within the leadership team, we thought, well, what are the kind of things we need to do to try and kick this culture off? And the first thing we did was we stood up and made the commitment. So it was myself, the project manager, and the facilities engineering manager, got the whole project team together, stood up in front of them and said, process safety matters to us. Process safety is a value, and that value is going to be unchanging throughout the project. Some of the underlying priorities will vary depending on what we're doing, but that underlying value will not change. And when I spoke to Alan about this before the conference, he said, that's quite a bold statement. For me, it was actually quite a scary one, because now the horse is off the blocks, and we've declared their commitment to this, and now we need to make it happen. And we had asked the whole team to hold us accountable to that, and if they thought that we weren't walking the talk, we wanted to know. Of course, it's very easy with these things to say one thing and do another. And one of our first big tests came quite early in the project, when actually one of my team stood up and said, you know how we need to do a line-by-line HAZOP later in feed? And I said, yep. And Chevron mandates line-by-line HAZOPs, even in the feed stage. He said, well, actually, your schedule's not going to allow for that. He said, we're probably going to have to extend the schedule about 6 weeks to fit this in. And just to compound the misery, he said, by the way, you're going to come out with about 2,000 actions out of this HAZOP. So, okay. I said, what's the solution? So we sat down and we got a small team together to work through a solution. And the first thing was that we set up a series of targeted P&ID design reviews way ahead of the HAZOP. And the idea is here we'll strain out all the big ticket issues before they ever get to HAZOP. and then you'll have fewer actions coming out of the HAZOP, and it should be a better study. The other thing is that the project manager stood up and publicly said, yep, I accept this, and we're going to delay the schedule for 6 weeks to ensure that this HAZOP happens. So that was a great opportunity. Not only did we get a better result at the end of the day, but people really got the message that we meant business. The other thing I'd bring up in that just briefly is that if you think about all the different groups that might be involved in making a difference in process safety, you would mention things maybe like the facilities engineering team or the safety engineering team. Actually, groups like the planning functions and the contracts people have got a really key role to play, because things need to happen in a logical order, and contracts need to be available at the right time. So we really are all in it together. Okay. I've mentioned about consistent message. That's always important. We've got to be able to walk the talk. But another thing we wanted to do was ensure that we didn't have siloed thinking, and we didn't want any us and them between the Chevron and the contract teams. So we got everybody together, and we used the old technique of roles and responsibilities. And we said, right, the contract teams, you guys have got the expertise to design this installation. You've got the expertise to design it safely, and we'd like you to do that. For the Chevron team, we're here to assist you in that process. We're not here to do the design for you. And of course, at the end of it, we want to verify that the company expectations have been met. And the reason to bring that up is that we wanted to get good group dynamics in the team, and we can only do that if people know what their roles are and they're not tripping over each other. If there's one thing to take out of this whole presentation, it's this next point. You need to be open to hearing bad news. Bad news is actually good news, because it's an opportunity to deal with a problem before it becomes critical. And it's much, much better to hear it from your own people than hear it from the regulator. And I know this, having been a regulator. But here's what really motivates me around this. Very early in my career, I was fortunate enough to sit beside Brian Appleton at a company dinner. And Brian Appleton was one of the 3 assessors to Lord Cullen in the Piper Alpha inquiry. And he said over dinner, he said, constant good news, you worry. When I asked him why he said that, he said, well, in the months before Piper, he said the permit to work system hadn't been working properly. In fact, it hadn't been working properly for a long time. And the audit process that was behind it wasn't working either. In fact, it was just sending out constant good news. So Occidental's leadership didn't realize they had a major problem in the offing. And as I heard them say that, and I was only sort of 22 at the time, only just into my career, which probably ages me a bit, I thought, I'm not going to let that happen in my watch. So I managed to persuade the project manager to stand up with me and say, if there's any bad news coming up, we want to know. We want you to tell us. I did wonder how convincing we are. You know, would folk actually believe this stuff? It turns out that they did. And about a month later, I get one of the electrical designers coming to speak to me about the electrical system. And the reason he does this is because electrical engineering was my original discipline. And he said, you know, this electrical design we've got here, he said, it just ain't going to work. He said, it's not practical. And when I asked him why, he said, well, we've got one local electrical room, combined switch room and instrument interface room at the back of the vessel, at the stern of the vessel, just forward of the accommodation. He said, the problem is that the vessel's over 300 meters long, and the cable runs are going to be so long and the cable's so thick, they won't actually fit into the terminal boxes of some of the equipment that they're powering. So, okay, all right, you've convinced me we do have a problem here. But you might think it's not really a process safety problem. Well, it turns out that it is, because the technique we'd chosen for most of the instrument circuits was intrinsic safety. And that works by limiting the energy in the circuit so that it can't create a spark that can cause a fire or explosion. But the cable lengths were so long that that technique wasn't going to be applicable. So we heard what they said, and we thanked them for it and asked them to go off and redesign the system. About a month later, they came back with a new conceptual design that involved 2 switch rooms midships. And what this meant was we had a more practical design, a design that was inherently safer because we were able to use intrinsic safety techniques for the instrumentation rather than other techniques like flameproof. And the other interesting thing is it reduced the overall cost because the amount of cabling was less. And the reason I bring this point up is we were open to hearing the bad news. Somebody was brave enough to bring it rather than just let things go on. And perhaps the most important point of the lot, you sometimes hear folks saying that safety and cost, it's an either-or relationship. It's not. If you get the right people in the room working together and you get the right thinking going, you can have both. The final thing I'd like to bring up here, again, it comes back to this theme of structure, is we created a process safety leadership team. Now, this wasn't simply the project leadership team rebadged. It was a group of people, a horizontal and a vertical cut right through the organization, that were tasked with one specific purpose only. It was to measure and guide the development of the safety culture. These guys weren't there just to drive another set of design deliverables. Organizational capability is a term you hear a lot in Chevron, but basically what it means is it means having the right people in the right place at the right time. So we did put a lot of effort into ensuring that we recruited the right people, both through the Chevron system and with the contract partners. And the one key thing I think to take away from this slide is the issue of co-location. I've seen it done before in projects, but it's quite often you'll find that the operators people and the contract folk will either be sitting in different floors of the same building or in completely different sections of the same building, barriered off with some sort of security door. What we thought was we want to get people talking. We want them to have the informal day-to-day discussions, what in Chevron speaks known as coffee pot discussions, that will result in a better product in terms of process safety. So we actually get folk co-located in the same floor, easy to move between sections of that floor, even Chevron and contract folks sat side by side. And it did 2 things. It did facilitate those discussions, but also sent the message that there was no us and them. And that actually is how the electrical issue got picked up. Thinking about our own team, we had a large operations team who were all very committed to this whole idea of having a good process safety culture because they were going to be the ultimate owners of this installation. But they were also able to give a lot of good advice on what would work practically and what wouldn't in the West of Shetland environment. There's a term in aviation called crew resource management, and that talks about using all the resources available to solve problems. We had 2 great resources available to us. Back in the business unit in Aberdeen, there's a technical authority framework. See these guys like super subject matter experts, and these guys were able to engage at various stages of the design to suggest what would work, what was practical, and what would result in a better design from the point of view of process safety. And last, but definitely not least, we get some really good input from the partners, particularly at HAZOP stage, where they were able to provide some independent process and safety engineers that improved the quality of the overall study. I could probably talk on this issue all day, but trust me, I won't. But the key thing about verification schemes are they can drive focus. And the thing that really drove me about this, it comes back to Piper Alpha theme again. This time, fast forward 23 years, and this time it's Lord Cullen that's speaking. And Cullen talked about his vision for the whole safety case regime and how he saw the real value in the safety case, not as the underlying document, but all the thought process that went into developing it in the first place. And I decided, okay, when we develop the critical element performance standards for Rosebank, we are not going to be in the position where they're developed in splendid isolation by another group and just handed over to the project team. So what we did was my own team drove this process, and we got all the relevant disciplines working together to create the performance standards around each critical element. And these were the performance standards that helped us work out together what these critical elements that are effectively the barriers between you and your major accident hazard were there to do. And it was then able to drive the underlying engineering. And I think we got a much better result out of it. One thing I did notice was there was much more buzz around this stuff than I'd seen in previous projects. And I'm sure it's just because we get people involved in developing them rather than going off in splendid isolation and just handing them over at the end of the day. The other thing I would point out from this slide is the need for realism. And you'll see that there's safety and environmental critical elements. We knew that the law is changing. It changes in Britain on the 19th of July this year, and we wanted to make sure we future-proofed the design. You've heard others talk quite eloquently about incident injury-free and their journey in that process. It's been employed in Chevron major capital projects for a number of years. What we did differently was just refocus the conversation on safety and design, about post-first oil, but also about helping the guys in the construction yard construct it safely. And the thing I really like about incident injury-free is the fact that it's transformational. It's trying to change people from the inside out. What gets measured tends to get attention. And I've always felt in process safety, we can't be using lagging indicators. They're just not appropriate. So we need to have some form of leading indicator. So these things I've always felt are best developed locally by local people for local control. So we got the process safety leadership team to think about what kind of things we needed to measure. And these are the things they came up with, a much more diverse group of things than we might have come up with on our own. As my grandmother used to say, the proof of the pudding's in the eating. So you might say, well, you know, what was different? What did we actually achieve? Well, here, I think, are the main things that we picked up. The electrical issues I've already talked about. But I think this issue around the turret here and the windshielding is probably the best example of interdiscipline working. We all know that good ventilation is great for fire and explosion management, but west of Shetland, you can have way too much of a good thing. So the ops guys said, we're going to need some wind protection here. So what we did was we got the North-SOC standard to define what we're trying to achieve and various iterations of modelling until we came up with a design in the windshielding. When we passed it by the Hull, Moorings and Risers folk, they said, hey, just wait a minute. This won't work because the loads in the Moorings and the Risers are too great. So what we did was we got the whole team working together, led by the safety engineering team, to come up with a result that did meet the needs of the operating team, but also minimised the loads in the Moorings and the Risers. And the other thing to pick out from this is there's one group that took the lead with the accountability, and a whole load of others helping. The final one I'll mention is the offset helideck. And you might think, you know, it's a major hazard management issue. Helicopter travel's a key risk, but it's not really a process safety issue. I would argue that it probably was. And the reason being that if people can't crew change regularly, morale's going to suffer. And when morale suffers, all forms of safety are likely to suffer. The original design had the helideck along the longitudinal axis of the vessel, so it's right slap down the middle at the back. However, that, although it minimised motions, isn't good for the pilots because they don't have a visual horizon when they're coming in to land. The other problem is you're getting turbulence off the buildings. And the third thing is you've got all these hot air gas exhausts at the back that create turbulence as well. So we got the aviation people, the marine people, and the operations team together, and work through various iterations until we come up with something that we think will work for everyone. You know, working together, it produces much better results, and it's also a whole lot more fun. Thanks very much.